All right, we're going to jump right into this. So this is the results of the best amount of research that I can do. Now, when I do research, R being the research being the principal meaning of R. Don't put Rust out there again. Why are you blowing up Rust right now? We're not talking about Rust. No, we're not. So, anyway, by the way, my feelings on Rust have totally changed within the last few days because of the whole other thing that we've been talking about. So please don't. We're not going to talk about that right now. I did talk about Rust a little bit yesterday because we were talking about Firecracker and how I think Rust could be kind of the golden child of the micro virtualization emerging. But that is unrelated to what we're going to talk about right now. So I'm going to try to look away from the chat, but let's try at least for the next 45 minutes to 90 minutes to stay focused on one topic so that we can have this YouTube video be kind of to the point. What is going on with containers, and specifically Kubernetes containers in 2022? And we're about to start KubeCon on Monday, so there's going to be a lot of other new content and announcements, I'm sure. But this what you're seeing on the screen right now, and by the way, if you want to join me, let me post the link one more time. If you want to join me and move your pointer around and participate, you're welcome to do that. This is a read-only Excalidraw thing. I'm a huge fan of Excalidraw. Full disclosure, I was gifted a membership to Excalidraw from one of our community members, and I've never looked back. It's so amazing. I've also been posting the PNGs of this to the Discord, so if you want to see those, you can go there. But you should be able to use the URL anytime to come to it. Okay. Now, this hey, look at all these fun little arrows. So what I'm gonna start by saying is a disclaimer. I consider myself, I've had people call me advanced in Kubernetes compared to the average Kubernetes admin, and I don't feel that way myself. I don't know if it's imposter syndrome or what. I feel like I've installed several clusters and I administer one, but I still feel like I'm always learning something that I should have already known. And this video right here is about that. It's about one of the things that every time I think I understand it, I get introduced to a new piece of the puzzle, and I'm like, oh, so that's how that works. And short of looking in the source code, which I am very prepared to do, this is the best that I could come up with. So I say that as a disclaimer because there might be some glaring mistakes in here. And if they are, and you're on YouTube, just let me have it. Write it in the comments. Say you got this wrong, and you got this wrong, and you got this wrong, and I'll go in and I'll fix it so we can have our hopefully corrected version of this. And the reason I put that out there is because in order for me to even come to this knowledge that I am showing you right now, I had to sift through a ton of bad information on the internet. Bad information, misused terminology, confusion, renaming, reorganization of projects, and all kinds of stuff. It's a pain in the butt to get to this. So I'm really glad that I was able to leverage my research skills to get to the right thing. So the overall topic for the next 45 to 90 minutes is going to be Kubernetes containers in 2022. And let me ask the question. First of all, why do you think you know this? And please, if you have input, please let me know. Why do you think understanding container engines in 2022 is important? Why is understanding container? It's pretty obvious to a lot of us, but what's your best way of succinctly saying that? Why do you care about the container engine when you're deploying Kubernetes? Why do you care about Kubernetes in general? Why do you care about container engines in general? Does anybody have any input on that? You can go ahead and throw it out there in the chat if you want to. But I'm going to submit to you that the reason that you should know about Kubernetes container engines is because they are the very basic elements of everything that you use in Kubernetes. Kubernetes is described as a container orchestration framework. So if you don't know what containers are, then you're going to be totally screwed up. So we should probably talk about what containers are versus virtualization. We talked about that a lot last time, and about how I think that the future. In fact, we have that in a different diagram. I'm just going to refer to it really quickly. In my air-gapped home network yesterday, we were talking about, this is my conceptual thing. We were talking about, Kubernetes. So I've decided to do a Talos cluster over here out of Optiplex servers if I can get Pixie Boot to work. We have open PBS for batch processes, and then we have a traditional on-prem Kubernetes cluster here, and then we have all of these VMs, potentially micro VMs, on our single VM server. So containerization and virtualization are important that you understand. I'm not going to dive into that right now. So we're assuming that you actually understand the difference and why they matter. And so we can jump right to the point where we talk about where we talk about just about Kubernetes. Okay, so wait, where did that come from? Did somebody draw that, or did I draw that? Did I draw that? I might have drawn that on accident. I did. Or did somebody else? All right, so no, Docker Compose is not a part of the diagram because this is Kubernetes containers. Who's drawing on there? Did I give somebody draw access on accident? Or did I do that drawing? I need to make sure that I didn't allow that. It might have just been a different color. That should not be there. I feel like something didn't get saved somehow. Yeah, that should not be there either. I don't know what happened there. Oh my god, it reverted my whole diagram. It did. It did. It reverted my diagram. This is a different version of the diagram I had before. It's got lots of stuff on it that wasn't there before. I'm kind of worried about that, but it's good enough. We can go with it. There might be a bug in Excalidraw. So let's go back to it. That was weird. That was really weird. All right, so back here we go. So there are some really strong opinions on this diagram, and I challenge myself to justify those all the time. If you want to challenge my opinions, please do in the chat. You can do it right now if you want to, or in Discord if you don't want to do it like right out of the gate. But what I'm going to start by saying that this is Kubernetes specific, so none of this has anything to do with other stuff. So like, for example, Docker Compose and any of that. So, and I think it's super important, especially now, that we start to think of containerization without Kubernetes as a separate beast. And this entire diagram is completely focused on that separation based on the container runtime interface as defined by the Kubernetes project, which was led by the Kubernetes project, but it's not necessarily just a container thing. It was something that came out from the Open Container Initiative. So let's talk about all of this and why this is relevant. So this first of all is for orchestration, and by orchestration we primarily mean Kubernetes, but it could have easily just been Nomad or anything. So I'm gonna try to get into this by telling you a number of stories. So the first story is, how did Kubernetes start? So Kubernetes, it was really quickly, Kubernetes started as a way to manage Kubernetes clusters, containers, and to run them in a way that could be easily started up again and all that. But the original version of Kubernetes depended on Docker, and Docker has always been a proprietary thing, and that was well and good. But then in 2017, they created the people behind Kubernetes came together and said, you know what, Kubernetes probably shouldn't be depending on this ever-changing underlying deep, low-level API from Kubernetes. We should probably standardize that. So they created something called the Open Container Initiative, or OCI, and that led to the creation of the container runtime interface, which is this. So the container CRI defines the API used to talk to container engines. The CRI API comes from the Open Container Initiative formed in 2017 to deal with problems from Docker being proprietary and non-standardized. As of Kubernetes 1.24, all container runtimes must provide a full CRI implementation. And if you ever read anything about Docker shim, or any of these things, that's because, and I'm going to read it right here, Docker is a significant decline after failing to respond to the needs of Kubernetes, forcing the creation of Docker shim, and later hitting the industry with a bait and switch tactic to force enterprises to pay up. So Docker itself is in massive decline. Nobody's using it. People are abandoning it like crazy. Enterprises like mine, which is a huge multinational corporation, have decided to basically banish Docker from their entire enterprise. It's in massive decline. The founder of Docker has left to pursue other interests. The company was already in financial peril before, and it's just a matter of time before it goes under. That being said, it is still holding on to the maintenance of the number one container engine recommended in the certification exam for Kubernetes, according to the official Kubernetes.io site, which is Containerd. Now, those docs are kind of old. Those docs were created a while ago, and CRIO, which is coming out of the OpenShift world, has really stepped up, and it doesn't have as many bugs as before, and it's extremely lightweight. We're going to talk about that in a bit. And it's a full implementation of the CRI and nothing more. So Containerd actually has a lot of extra bloat on it because it tried to be more, and that has an advantage or a disadvantage. But the ultimate decision in 2022 is, in my opinion, is whether you use CRIO or you use Containerd. That's really, Kubernetes is an orchestration platform for Kubernetes, right? People have been saying Docker's in decline for 6 years. Yeah, well, I can tell you that a company of the significance of the one that I work for and the other ones that I've heard of who've decided not to allow Docker on the desktop ever and not to depend on Docker CE is actually been executed. I'm in the process of doing it right now. So, you can say, and so there's a number of reasons, even most recently. So Podman desktop, let's so the story, continue the story. So Kubernetes got started. Docker was a good player for a while, and then everybody's like, no more Docker, and they've been trying to get off of it, but Docker had such a stranglehold on the whole industry that they've been really holding on to it. And all of the other players weren't really that well implemented. CRIO had lots of problems like 3 years ago, 2 years ago, and it's since kind of come around from what I can tell. And so now everybody's like, no, we're going to use CRIO. CRIO is the standard thing to use. You should use CRIO. It's the best thing. But more importantly, underneath all of that is this thing that used to be called libcontainer, which is now called runc, which is the thing that actually does the container creation. It's the low-level library, Go library that talks to, I think it's runc in C or Go, either one. But it's the thing that actually does all the container creation and stuff. So that's really the biggest piece of this whole puzzle. And actually, Containerd used to use libcontainer. There was an ancient blog I read, used to use libcontainer, and then I read someplace, and I wrote this here. Where is it? The Containerd is still maintained by the Docker company. Officially requires some Docker C packages to be installed. The runc container runtime engine was once libcontainer, causing some confusion when researching the actual container source libraries used by the container tooling. So if you're like me and you like to get into the low-level details to see, okay, which libraries are the most popular, which have the most stars, which are getting the most usage, and what are, up the chain, what are the products that are using that, what are the projects that are using it, then it's really obvious right now in 2022 that anything that's not using runc is going to be completely irrelevant in this space at this moment. So in my opinion, runc is where it's at. And if you're not using runc, technically speaking, CRIO, which stands for the Container Runtime Interface -open or OpenShift, depending on who you ask. I've read both in 2 different places. Was created by Red Hat, and is meant to just fulfill the minimum elements of the Container Runtime Interface. So let's read about the Container Runtime Interface for a bit. So the CRI defines the API used to talk to container engines. I talked about that. Okay, so CRIO, CRI-O, which is either Open or OpenShift, allows you to run containers directly from Kubernetes. Now, it was designed for use by Kubernetes, but they were very careful to not say this is only for Kubernetes, right? So this is a container runtime interface which defines a set of operations. So you might be wondering, well, what is it really, right? So it's basically just, you can go read the spec. It's really long and boring, but it defines a set of operations which are implemented either through direct calls or through API calls or whatever. And the operations that must be implemented are create, start, kill, delete, and state. And you can go read about these in the specification, but those are the only things required by the CRI, by the CRI standard. And that is kind of an interesting thing. And I've discovered this through the hard way. So there is a tool that now ships with Kubernetes called CRI-CTL. This tool does not ship with CRIO. There's a dependency on it, but it's designed to be a part of the Kubernetes space. And as I said, so there's no like an interface and programming. Yeah. So there's the Kubernetes project is very good at not putting their foot down on something. It's kind of annoying. So like the Open Container Initiative was maybe kicked off by Kubernetes, but it didn't necessarily mean all things Kubernetes. So everybody's following it, right? So they're all implementing the CRI no matter what to talk to containers. And to tell you the truth, there is actually the hope that I think that maybe BSD containers at some point could implement the CRI. And if they actually do that, then that means all of this cloud native hardware and every software and everything could run on BSD. And there is nothing that says it has to be, LXC, Linux specific containers, as far as I can tell, in the specification of how to make the container interface work. So it's very possible that someday we might be able to do that. Now, that there's a whole big problem about how do you store the containers, and this little green dots here. I mean, these green things here, and that thing. So I don't want to get into that rabbit hole, but there is some standardization here. So if you want it, so the CRI-CTL thing, which as I understand it, gets installed by Kubernetes packages when you're installing those things, allows you to talk directly to, I think it's runc. I don't think it's directly to the kubelet. I can't remember. This one I might have wrong, actually. I think that this might does anybody know? I think that this might actually not be here. I think it might be to, I had at one point I had it pointing to the kubelet, and then I had it pointing to the runc. I think it might actually be able to talk to both, because I do know that when the kubelet is not running, because the kubelet crashes, right? You can get on CRCTL and you can run CRCTL list, and you can list all the pods on the machine, whether or not they're in the kubelet. And pods are static pods that have been defined on the host. That's what, all of that stuff is. And they are just defined in configuration files that point to containers that are running via runc on the machine. So you don't have to have a kubelet. CRI-CTL, I think, can talk to the kubelet, but it goes directly through runc to the containers on the machine. But it also has knowledge of the configuration files that the kubelet has access to. In fact, that is probably something I want to add here. Let me go ahead and add that really quick. So I think it would be safe to add like a configuration file icon here and stuff. So where is that doing it? Where am I? I don't want Zemo. So yeah, I think that let's do that. So that is the, wait, is that the fill? Oh yeah, we need to let's do white on this. I'm almost positive that that's true. Because it does not communicate with the kubelet. I know it doesn't need the kubelet to be there because the kubelet is not there when you do kubeadm init. But it can look at the file itself. So this would be the configuration file. So I'll add that in there. What's that? Those are possible options for components. Is that a minimum you need? When you're talking about a Kubernetes endpoint, you need a runtime, you need a kubelet, you need a runtime engine, I should say. You don't need, and this is another thing. There's some terminology regarding a runtime, and people have said it doesn't have a runtime. I've heard that statement 3 times, and I restated that to some other team today, and I was wrong. I did further research on that. To say that Podman does not have a runtime is a false statement. All right, so this is very, very frustrating because this terminology gets misused all the time, and I have read it at least in 3 places since I repeated it incorrectly. Yeah, but what is runc? Right? Runc, by definition, and I have at least 3 or 4 sources of this, is a container runtime. So I've heard at least 5 people tell me incorrectly that Podman, as far as I know, that Podman is a container runtime, and that's not true. And they've told me that CRIO is a container engine that doesn't have a runtime, and that I cannot overstate how wrong that is. And I just repeated it incorrectly. It's using completely wrong terminology. So let's get the terminology right here, okay? So according to the documentation, CRIO is a container engine that fulfills the container runtime interface. And it does so by calling into runc, which fulfills the CRI stuff. Now, containerd, which if it's not confusing enough, has its own component called CRI, which also fulfills the CRI and, in its own way. And I read 2 different blogs that said containerd doesn't use runc, and then I read another 2 blogs that were newer that said containerd now uses runc, and then I put it together that the other ones were saying that it used container lib or lib container, and then I actually read another blog that said actually runc is lib container. It got modernized, and that's its new name. So I just saved you like 2 hours of research to get that down, if that turns out to be true. Because that was so frustrating. I was like, what the hell are we talking about here? So as of this moment, knock on wood, I think it's safe to say that all of the major container engines that are used by Kubernetes all use runc. There is no other competitor to this. And so anyway, this is the problem with blogging, right? As it gets all outdated and everything. So when I was actually really happy to hear that because it simplified my graph, because before I had to have like another piece here or something, right? There was another thing that fulfilled the CRI, and I found out, oh, it's just runc, right? So is nerdctl only for containerd? Show me that in writing someplace. Show me that nerdctl can't talk to CRIO. If you could show me that in writing, I'd be happy to change it. If this is, because I think that's what that is, right? You can use CTR or that, right? I think that's right. Frankly, I didn't do any research on nerdctl at all. I've just heard people talking about it. I don't plan on using it at all. I just thought I'd put it there. So if you know for a fact that only talks to containerd, please let me know. There is a CTR command that's documented in the Talos documentation. It's also documented in the kubeadm init documentation on the official Kubernetes site. So in fact, containerd is still, as I said, is still front and center when it comes to certification. It doesn't have anything on the certification preparation materials for CRIO at all. It says this nerdctl Docker compatible CLI for containerd. Docker compatible CLI for containerd. Okay, well, that actually really helps. Thank you very much. That's why I'm doing this. All right. Yeah, I didn't even go there. I didn't know. I didn't read anything about nerdctl at all. Little or nothing. I just put it on here because people keep recommending it. So that's good to know. That's good to know. So containerd is still a really strong container, but let me tell you the reason I'm not using it. Containerd is still maintained by the Docker company officially and requires some Docker CE packages to be installed, causing confusion. I did this last year. Last year, I installed containerd as my runtime engine, and it forces you to do, sudo pack apt install or DNF, whatever you want to do. I had to install Docker CE in order to use containerd. And I was like, what the hell? Because there were packages from it. And they have never, as far as I know, they haven't separated them. So when you read the documentation for installing containerd, because it's the same thing that's used in Docker now, you'll read all this conflicting information about how to install it. It turns out that I had to follow these installation instructions, and then I had to go in and change all of the defaults that were installed by Docker CE so that they would use only Containerd. And that step was a pain in the butt. It took me like an hour to do it. It felt like a year, but it took me like an hour to do it. And Containerd filled the same role. Well, I know that's what we're trying to get at. So we have JS libraries that probably like the next best thing has come out every week. Yeah. Yeah, well, the fact of it is every time they do that, they also complicate things. But also, I mean, the abstraction of the interfaces, the CNI as well, which is the networking part of all this, we haven't even got to that yet. That completely complicates it even more. So, you have to know about these things. And then we got micro virtualization coming on the scene too. So anyway, so this is my attempt to simplify this and make decisions for myself and to stand by my recommendations for other people. Okay, this is something that's very rare to find in our industry. There's a lot of people that will tell you all the possible ways to do things, and they'll have very few opinions. And I'm going to tell you why I chose to do these things. I mean, Talos, of course, all of this stuff is irrelevant, right? Because it's all black box. It's all hidden from you. But, there's other considerations for that. So if you're installing your own on-prem Kubernetes, you need to know about these choices. And so, I mean, I still think it's extremely confusing that the name Podman has nothing to do with pods at all. Why did they name it Podman? I need to drink after that statement. Red Hat, can you please change the name? That'll just confuse us all even more. There's nothing to do with the Kubernetes pod in the program Podman. Not at all. There's not a single reference to pods at all. It just happens to be misnamed. It has pods, but they're different from Kubernetes. Oh, that's nice to know. Okay. All right. I'm going to update I got to make my thing more accurate then. Actually, Podman, as if it wasn't confusing enough. Podman does have Kubernetes, does have pods, just not Kubernetes pods. That makes it even worse. That makes it even worse. I mean, the foundational concept is the same. Of course it is. But God help you if you think you're going to be able to go check all your pods on an endpoint with Podman. If you install Podman on your endpoint, this is another thing that's really dangerous because I did it. I'm about to tell you another story of something I did that I learned from that I'm going to save you some time on. So it's like, I was going through doing my Kubernetes installation, and I needed to get a container in order to use Vault. In order to use Virtual IP, kubevip. In order to install kubevip, which is a load balancer, right? I had to have a running Docker instance, a container engine on my endpoint, but I wanted to install it on the control plane, and my control plane, I had CRIO on there. So I'm going to tell you my sad story, okay? So don't be me. I was like, okay, I picked CRIO, I picked the lightweight engine and everything, and that's where I learned this important lesson. That just because something is CRI compatible does not mean it's going to have run or exec or any of the other stuff that you expect when you're going to use Docker or Podman or any of these higher level tools. So what happened? I went in there, and the documentation for Kube VIP says either use CTR to install the container that then you can then run, which will then install the software. You have to have a container engine running and Docker, in quotes, to even install this static pod, which makes no sense at all. But in fact, I have soured on that entire Kube VIP thing now so much because of those decisions. And there's a huge thread on their support channel about how confusing this is for new users and all this other stuff. And now the fact that CRIO is like the leading container engine has further complicated the issue, and they don't even have anything there. In fact, everybody's pushing for the Kube VIP project to just put examples of the config files for static pods, which just have config files in the API, to put just leave that and just let people figure it out, because they don't need to install this container runtime. So because of all of this crap, I mean, I lost 2 hours on this shit. So I'm saving you some time here. So I was like, okay, I'm following the instructions, and it says that I need to install it says I need to install a Docker engine or something like that, a container engine, and then I needed to run it as a way to bootstrap the manifest system. Yeah, I agree. And so it either lists CTR or Docker. That's it. CTR or Docker. So what did I do? I assumed, well, okay, I'll try. I didn't have CTR because I didn't have a container runtime engine. So I made a bunch of bad guesses. And the first bad guess I made was, oh, I'll just use CRIO-CTL because it has a list command. It shows me all my containers. It shows me all my pods, and I don't even have to have a running kubelet. This will be awesome. I'm sure it's Docker compatible. And no, not yet. We will. And so I went to go see if it would work, and it didn't work. Obviously, why? Because CRIO-CTL only deals with pods. And pods, yeah, sure. We had some people tell, oh, it's fine. It does containers. No, it doesn't do containers unless they're a pod. So if you have written all the configuration file to turn a container that's on the system into a pod, yeah, it's happy to play with that, and it'll do it. And you can run it. You can start it. You can't run it. You have to start it because it implements the minimum necessary for CRI, which is create, start, kill, delete. There's no run. Okay, so that was the first mistake I made. I was like, I cannot do this. And then I had a whole bunch of people on the stream telling me, yes, you can. You just have to turn it into a pod. I'm like, I just want to run a stupid install script here. Why did they not give us an installer? Why did they not give us an install script? Why didn't they give us config files? And everybody came up with opinions that are like, oh, blah, blah, blah. And I'm like, look, I'm the noob here. I just want to use this thing. And I about threw it all out because of the bad installation steps, because of all these complications that they didn't even think about. Yeah, create your YAML and then you're good. You just copy and paste it. But it doesn't say that in the documentation at all. It says your best way to do this is just go run the container and do this thing. They could have just provided like a bash script and been done with it, or any of these things. They didn't do any of that. And that frustration was enough to almost send me down the HA proxy path, which is completely separate from all of this stuff, which runs under its own daemon, which I would probably run as a VM completely outside of Kubernetes if I ended up doing that, which is a load balance. That's a different topic, but the Docker C, I think they should. A lot of people agree with it. They should do this. Anyway, I mean, I lost hours on that. And so did everybody else that was watching this. And I'm saving you the time by looking at this and knowing, don't do that. And the reason it was so annoyed by it that I actually read I briefly scanned, I should say, the entire CRI specification to see why this command isn't in there. And that was when I uncovered that only create, start, kill, and delete are truly supported. They're the only operations required by the CRI, by the entire specification. So I was like, okay, so mistake number two that I did. I said, okay, well, if I need a container runtime engine over there and I need to get to these containers, I need to be able to I need to follow the instructions, which are Docker run, right? Or CTR run. I'm like, well, there's no Docker, there's no CTR. What's my next best guess? Podman. So, I mean, I was like, well, Podman is supposed to work with everything, right? It's CRI. It's got CRI built into it. I'm sure that will work. Wrong. So I installed Podman onto the Kubernetes plane so that, for one reason only, just so that I could run the container that would then, start and install my KubeVip, right? And it worked. It worked. It installed it just fine. But then later on, I started noticing that what the Podman was showing me was completely different from what CRIO-CTL was showing me. And I noticed that they were looking at different sockets or different services and things completely entirely. And then I realized a very, very important lesson. And I cannot overemphasize this enough. Do not mix your CRIO container engines on a Kubernetes node with any other high-level runtime management tool. Just don't do it, because you cannot be sure that they're going to use the same thing underneath. In fact, the very nature of the engine makes it so that they have radically different ways of implementing things. Containerd has its whole socket thing. CRIO has got its own service thing. And you know what I'm saying? It's like, there's just a ton of reasons not to do that, because the way that containers are implemented by the engine, even if the underlying LXC stuff is the same, because that's what this is all into, right? But that middleware between the person talking to the container or the thing talking to the container, person or service, and the underlying LXC, execution of the containers, the stuff in between there can radically differ. And this has been the whole area of the fight between CRIO and Containerd. Containerd is insecure. I mean, they fixed a lot of it now, but CRIO does not have privileged. It doesn't have a socket that's running as root. All the things that Docker just got beat up over for just doing poorly, like inefficiently, poorly, and insecurely. Docker just really messed up. And they just never intended to fix it. And so Containerd has tried to kind of fix all those things over the years and say, well, yeah, okay, we did that wrong. If you want to do it this other way, do it this other way, but it's not the default, blah, blah, blah. It's a pain in the ass. The bottom line is that the stuff in this middle layer here, right? The stuff right here in this middle layer is so different depending on the stuff in the top layer that gets installed that you just don't want to mix the two. Do not cross the streams. If you do, you're going to get burned. And I'm going to read the statement down here that goes with this. I'm going to zoom in on this a little bit and read this. But this summation down here with the explosion is my conclusion about this. So with CRIO containers, the CRIO containers must be put into pods to run them at all. All right. So this is considered good because using a container runtime for anything but Kubernetes on a Kubernetes node is considered bad practice. In fact, when I suggested on the stream while I was doing this that our company regularly does this because they don't allow users to have their own Docker, and they regularly tell people if you need to run Docker for anything, just go get on one of the head nodes and run Docker straight up on it and just reuse the Docker container engine on there. That's also running the control plane containers and pods on there. That is like a really bad offense. It's not the kind of thing you're going to get fired for yet. But when I mentioned that on the stream that people were doing that, people were laughing their asses off. They were freaking the fuck out. They could not believe that any company would ever allow that, because it's not only is it insecure, but it's just asking to blow up. It is. It's asking to blow up. It's absolutely horrible to do that. Now, I tried to make the case wrongly that, well, what if you only have one machine? Then you have to decide, and maybe you want to share both of them over there. You know what I mean? And the fact of the matter is, thou shalt never ever use your Kubernetes nodes, the container engine on your Kubernetes nodes, for anything but Kubernetes. Here's some criticism to make VMs on ES6, of course. So here, yeah, right. And so let me just continue reading this. So it's considered very bad practice today. It is also bad practice to install Podman or any container, utility on a node because the engine used may not coincide. And it may it'll still use LXC down at the bottom. It has to, but the stuff in between there is totally different, whether it uses a service or a daemon or a container. So it's not going to be what you would expect, right? And so as you become familiar with the internals of how, CRIO uses its thing, which is a service, then you know that how to do that. But Containerd uses a socket, which is totally different. It may be that there's multiple options for both of them, but the point is that you can't be sure that your apt install or DNF install Podman is actually going to do the same thing that you used when you installed your container runtime engine, which is whether it's Containerd or it's the other thing. So do not mix the two. If you mix the two, you're just asking for pain and hurt, even though you think it might be saving something. It's not. It is also bad practice to install Podman. Okay. As a rule of thumb, use CRI-CTL for pods, containers on a node, and I said the word pod there on purpose. Right? CRI-CTL cannot directly access containers, period. It doesn't have to go to kubelet. That's why I drew that little picture of a configuration file. So if you have static pods on the machine, it can talk directly to those pods, but it has to have knowledge of those pods. That means it has to see the configuration file to know how to wrap up that container and put it into a pod and then access it using a pod. And of course, you can't use kubectl on the endpoint without kubelet. That has to have the API, as far as I know. So as a rule of thumb, use CRI-CTL for pods, containers on a node. Everything on a node, for everything on a node. And Podman, despite the horribly confusing name, or nerdctl for non-Kubernetes containers. So, you know, we can use containers are still very relevant. So people were asking me about Docker Compose, why that isn't on here and stuff, because Docker Compose and these top level things, these top level things up here, they're nice and good and all, but they're not really, you know, these things up here, these things do not have to be associated with Kubernetes. But that is an entirely different approach to containers. And I really want to emphasize that in 2022, the best thing you can do for yourself as a beginner or as a veteran is to think of Kubernetes containers differently than everything else. Because if you do, you'll save yourself. You say, well, they're all just containers. And yeah, okay, they're containers at the lowest level. They're all using LXC. Okay, that's true. But everything in between there and you is totally different, depending on whether you're doing it for Kubernetes or you're doing it for Docker Compose. And to save yourself a lot of pain and suffering, I cannot overstate this enough because I went through hours of it, that you need to separate those concepts in your brain. And should you learn Docker Compose? Yeah. Should you learn Docker Swarm? I don't know, maybe not. And Docker Compose is not bad. And you can do Podman Compose too, right? Those are things that are for a totally different approach. And frankly, we need to have, in fact, from now on, I'm going to refer to them as Kubernetes containers and probably Docker Compose containers. Because those, to me, that's the biggest separation, right? If you're using Docker Compose, or you're using Podman Compose or whatever, but Docker, as soon as you were Docker and Compose, you're like, oh, we're talking about that. You're talking about all the container wonderfulness that doesn't have anything to do with Kubernetes. But when you start talking about Kubernetes containers, you're talking about a different beast altogether. Even though some of these things have similarities at certain points in the architecture. Whew. Now that seems like a lot to say, but I really feel like I finally understand it. And I just had to capture that really quickly into a video. That's all I have for this specific video. And hopefully that will save you some pain and suffering as you go about your Kubernetes admin installations and your all of the other stuff that you might end up wanting to do. This diagram is available anybody to come see. I'll put it in the Discord, and I'll be using this diagram to make sense of my world as I go about the installation of the next thing I'm going to be doing. I'm going to be installing these clusters, and I did we save this already? I think it saves automatically, actually. It's supposed to anyway. But so yeah, the next thing I'm going to be doing, which I may or may not do tonight, is I'll be installing some other Kubernetes clusters over here, and we're going to go back to using kubeadm for that. I do need to install Vault so I can get some PKI root CA stuff. And I need to get my head around how I'm going to manage VMs on this machines, because I'm going to be running Core DNS and Keycloak and Vault and all of that stuff before I go forth with my kubeadm installation, which is probably not going to happen tonight or even tomorrow, but I am going out of town for next week. Yeah, and you like Vault? Yeah, so just to give you an overview of what's next and why this might relate. We use Builda a lot. Yeah, so Builda is actually built into Podman. That's another thing I like about Podman, is Builda is built into it. And Builda is it's all it does is just build the images, right? And Scopio is another good one that'll transfer, containers between registries and stuff like that. So yeah, just to finish out the idea about where this is going, I keep drawing on here because I'm still got that selected. The next steps are probably, since I got my whole VLAN all set up, I'm so happy about that. There's a video on that if you want to watch that. We're going to go ahead and, where does Istio fit? Istio is just a service mesh. Yeah. So we are going to do Istio, but it's going to be like the last thing. The main thing Istio gives you, it gives you lots of things, but the main thing it gives you is like virtual servers that have domain names that get load balance and stuff. Yeah. Yeah, we still have to pick a CNI and all that. So a couple of changes just to update everybody who hasn't watched. So this is going to be the Talos cluster over here. Right now I'm doing some testing offline to see if I can TFTP boot one of the Dell Optiplex machines that I already have. There is some problems with the Pixie boot, and it requires you to push F11 to do the booting. So that does annoy me a lot, actually, and because I can't. I don't know. I'm really tempted to just throw Talos out for now. As soon as I read that Talos cannot do, I mean, this is another topic. I should talk about this, not right now, but when I found out that Talos cannot, that these machines cannot do true Pixie boot, that anytime Talos requires being able to reboot the machine, and I have not gotten around. I need to ask somebody from Sodero or Talos. I was like, well, what happens about that, right? So I want a totally, hands-off installation and management of Talos. That's the thing that they keep promising you. But if every time I reconfigure a server, I have to go in and touch every server and reboot them, I don't. It's a non-starter. I don't even want to do that. Thank you for that. So I'm. You know what? I'm just gonna make a decision. I'm gonna throw these out. I'm gonna throw Talos out of the environment for now. I got too much other stuff to deploy, and we will go with that. It might be that I do PBS for this. We don't know. KGCP from ISC. Yeah. Did you know that? Did you hear that we found out that ISC DHCP is supported on OpenSense? That's the DHCP it uses. So you can go in there and edit it. The problem is you got to save your files someplace, because if OpenSense, if you update the firmware, it'll throw out your entire configuration. So it will back it up for you, but it's something that's kind of, I found out, is it? Yeah. I think the key DHCP server is probably going to be the one that I'm going to install. I am going to install a DHCP server on my internal VLAN, but I don't know how much of a priority it is right away. For years, very, very fantastic, very good stuff. So I mean, as far as YouTube goes, I'm going to go ahead and end that video here. So just as a follow up, so have fun with that, with the container runtime engine. Maybe play around with it. The last thing I will say, for a very long time, I was anti Podman, and I was wrong. I was wrong for a number of reasons. But the most important reason that I was wrong, I was mostly wrong because I was looking at how Podman managed the container. For example, Podman does a lot of magic to the container. For example, it injects systemctl into any pod, or stuff that enables systemctl, to be more specific, because they make a big case at Red Hat that containers should be able to simulate machines, and be basically miniature VMs, which I completely disagree with. I think use a virtual machine for a virtual machine, and don't use Podman for that. It was annoying though, like a year and a half ago when I was doing the boost and we were using containers, because I couldn't simulate the installation and management of services the same way you would on an actual Linux virtual machine. And that's one of the main reasons that we switched over to because when you're doing like systemctl, restart, whatever, HTTPD or Nginx or whatever, those kind of commands can't be done in a container, and they can't be practiced in a container. But if you just need access to a terminal to practice bash and stuff, great. But if you want to practice systems administration and on whatever, and I think you need a virtual machine, which prompted the change to use virtual machines in the boost in 2022. So in 2023, however, I'm strongly, I already decided that we're going to be doing all 5 ways of getting Linux, which I've mentioned before. And one of those ways is Podman. And the reason I'm even saying about this now is that it's Excalibur. You guys want to copy again? So as I've said, what was I going to say? The Podman. Now I've tested it in 3 different machines. I've tested it on Mac, Linux, and Windows. The Podman desktop installation process is as easy as Docker desktop used to be. I need a lot of commands. The command thing wasn't even working till yesterday, so I'll update all of that. I need lots of things. I also need help and time and a clean room. Okay, so So we will be providing instructions about in the boost about how to get Podman up and running on your desktop. But I just want to kind of conclude this YouTube video with that. If you haven't tried Podman out yet on the desktop, whatever your desktop is, you might try it. Something else I'm super interested in is that Podman actually chose to use QEMU and KVM, which is exactly what Docker Desktop does, by the way. Okay, here's a fun fact that you might not understand. I'm going to actually sip some wine for effect. Here it comes. You cannot run a container on anything but Linux. Someone explain that while I take another sip of my wine. You cannot run a container, if you want to get really pedantic with your friends, pick you up, you cannot run a container on anything but Linux. A modern container, a Docker container. If you want to put the word Docker in front of it, you cannot run a Docker container on anything but Linux. BSD has jails. They are not Docker containers. So if you want to use the word that people will recognize, the statement, you cannot run Docker. And then, but I run it on my Mac all the time. No, you don't. You do not run containers on your Mac. You do not run containers on your Windows machine. You don't even run containers in WSL. On Mac, they use a compatibility layer. And on, you know what the compatibility layer is? QEMU. Docker Desktop and Podman Desktop, and I assume now Rancher Desktop, all use a minimal virtual machine that uses QEMU in order to emulate Linux. And that's how they do it. They all do it. And so I was actually looking through the internals of the Podman. I'm like, what are they doing here? It turns out they completely straight up copied what Docker Desktop was doing. Docker Desktop has this nice, happy, Electron front end to everything. But under the hood, it's running QEMU. And I think Zen, it's not Zen. No, it's not Zen because it wouldn't run on the hardware. Containers need C groups for Linux kernel, I think. Yeah, LXC, C groups and LXC are what modern Docker containers are defined to be. So you cannot have a Docker container without Linux. So next time you run that on Windows or whatever. But there's something else I want you to consider here. It used to be that I would complain, people, or I would be like, well, God, I got to install a whole virtual machine. In fact, Podman was kind of slow to do Docker Desktop. You know why? Because they're pedantic engineers over at Red Hat, and they're like, well, you got to have Linux anyway. Why don't you just install your own VM and just do it that way? Am I wrong? That was Red Hat's position in my mind up till last year or within the last 3 months. Before that, they were like, you know what? Podman's like, we don't need this stupid desktop stuff. Nobody needs that. I mean, everybody knows that containers have to have Linux anyway. They'll figure it out, and then they'll install a VM, and then they'll put Linux on there, and then they'll do Docker as God intended by installing it on Linux using Podman install. They can do apt install Podman or DNF install Podman or whatever they want. And so Red Hat missed the whole desktop market by saying, just do it that way. And then what happened? And then last year, Docker famously said, psych, y'all have to pay us now if you're a certain size, which is pretty much everybody using it. And Docker perked their ears up and Rancher perked their ears up and like, oh crap, there's no free desktop option anymore. People will stop using containers and be annoyed by it, and they'll stop using our other products. We got to fix this. And so I imagine somebody over at Red Hat, like, damn, we got to get on this. So then Rancher Desktop and Podman Desktop kind of seem like they're in a race to see who can make the best desktop container option. And now we have last week I tested it all out, and Podman works wonderfully on everything. It's really weird that it uses WSL instead of WSL2. I think that's very interesting. Probably because of the hypervisor dependency, but I don't know. Our instrument Windows is on Linux containers. Yes, you can. That's pretty cool to have that, isn't it? Anyway, so where virtual machines in disguise behind a poorly optimized Electron interface. I know, exactly. I mean, you know, in retrospect, I got to tell you, it actually has improved my my position on what I think of Red Hat, because Red Hat's like, no, we're not going to do that. We're not going to bundle a bunch of really beautiful garbage. We're not going to put lipstick on this turd and get people to use this virtual machine that's going to screw up. Docker did it because they wanted the user experience to be nice and easy. That's what made Docker famous. Because the Linux LXC people forever have been saying you can do containers, and Docker comes along and says, well, yeah, but the CLI sucks. There's no way to do it. The average person can't do it. So we're going to make this nice, pretty, happy command line thing called Docker. And guess who gets all the credit? Now they're called Docker containers. They're not called Linux containers. Everybody who worked on the LXC project and C groups and all the people who made containers happen, which have been around for more than 2 decades, about a decade, I think. Probably something like 2011 or something. They're like just, you know, smacking their foreheads, and they're like, what the hell? As along comes somebody who cares about their users and is like, no, we're going to make a nice, happy front end interface to this thing, to the, you know, great anger of all the people who were using containers the hard way, and they get all the credit. And then they decide to do this bait and switch on top of everything else, which just makes the Linux community fucking hate them, because they're, you know. And that part of the Linux community would have been, in my estimation, would have been the Red Hat. Red Hat is more a member of that technical part of the Linux community than Docker has ever been. And I mean, there's good people with Docker. I'm not attacking any specific individuals, but as a company, they've had really poor decisions. And so they won't call it good string C groups. No, they won't. I call them containers and container images. I don't say Docker. Nobody does anymore. Docker is more like Canonical in that sense. Docker has the user's considerations in the forefront, and they will violate good back-end architecture to make it easier for the user. And I think that's a good thing. I do. I think that we need to, it's a combination of both, right? And it took them doing that to get Podman to have a decent desktop offering. And I'm really glad they did that. So it's a big, you know, dynamic going on all the time, and many of the things I've said have probably offended many people very seriously here. I'm sorry. I largely don't care, because I feel like we need more opinions in this industry. There are just too many choices, and we need more best practice opinions, and we need to justify those opinions and say, hey, if you meet this criteria, this is what you should do. And we should have the courage to start saying those things and then fixing them when something better comes along. Otherwise, we're just going to be just floundering around like we have, like, for years, and we still will continue to do that. Both the Docker project and Canonical have always gone their way. The aspects that show typical signs. Oh, right. Yes. Yeah, but not invented here. They do that. Yeah. I mean, that's just a tech problem in general. But at the same time, I do believe, to their credit, that Docker and Canonical have been more focused on user experience than the technology. And that's not a bad thing. That part of it's not bad. So Red Hat wanted Docker to integrate better with systemd, but Docker just already said, nah. Yeah, Docker's been doing that all along. The whole systemd stuff, the systemd integration, and the, you know, they were trying to stand their ground and say we want to have an independent socket. And I actually agree with that. Yeah, I mean, for some of the stuff that I was doing, I was able. You can't do Docker in a Docker. You know that, right? You can't do Podman in Podman. It's impossible. Before, you could just remount the socket, and you could have a Docker running inside a Docker container. Use the same host container image. Now, some people would call that an absolute Frankenstein's monster of problems, but it's, yeah. The idea is it's just bad, but it doesn't matter because it was very practical. I use that all the time. I use that all the time because I didn't have any Linux on my system before I switched back over to VMs. Because, you know, and by the way, the VM is the clear way to do that, right? If you install a Linux VM, then that's not a problem. All your stuff lives in the VM. You know, you're good to go, assuming you can get a virtual machine on your machine. And so I think there's going to be a strong resurgence of VMs. In the world, but but the Docker thing was always kind of a hack, and by the way, it was actually used in pods. there's Kubernetes pods and stuff that would use the Docker thing, which is just like such a security violation. It's outrageous. So that's why people are owning it. But I did think it was useful for pipelines. That's why I used it. I used it for that for a long time. And there is no alternative in the Podman landscape. The CRIO landscape, Podman landscape is not there because it's insecure to them. So not enough for VMs. Yeah, and if you don't have enough for VMs, then you got to do the Docker thing. And so that was, it was a very practical thing, but it probably wasn't a good thing. For developers, it was nice, but for all the other reasons, probably not. With a VM, yeah. Not everybody has the option of running non-Windows on their desktops. I just read another blog from a guy who was super annoyed that he had to run Windows on his desktop at work, and it was all the ways he got around it. but yeah. And ruin the nodes quite often. You've seen DID pipelines in the wild. Devs how properly use Docker, not mess. Oh my God. Use NCI. DID was always using CI as tools to simplify stuff. So it's not that bad keeping things simple. I think that's right. And that's one of the reasons I think that it's a huge debate. It's very good wine. It's also the end of the wine. We don't have any more. But it's the weekend, and I hope everybody, I'll say cheers to everybody as I go get more wine. I'm going to go ahead and end the YouTube videos here. So I'm trying to keep the YouTube videos shorter. I apologize for how long-winded I am. And I do hope that this doesn't scare you away from all of this technology. I do find it extremely exciting. I think the movement in the industry is in the right direction, actually. All of this movement might make CI/CD more annoying and developer processes more annoying, but it's going to make for a more secure container orchestration as we adopt these practices. And it's going to ferret out a bunch of bad practices. So for example, putting CRIO as your container engine on your nodes, including your control plane, is automatically going to shut down any user who's using that control plane head node for Docker. And their process is going to break, and they probably should break because they shouldn't be mixing the two as we talked about. So hopefully this will be something that you can consider as you go forward. I don't know if I'm going to do another actual video tonight. I'm probably just going to be shooting the breeze on Twitch. And as a general rule, though, going forward, I'm going to try to start each one of my streams with a YouTube video quality content that's very organized and about a specific thing. And then we'll stop the video, and then we'll just do silly stuff for the rest of the night. So on Twitch, so we can start on a good note and get some value out of it, and then we can do the crazy stuff that I tend to do. All right, so if you want to come join us for the crazy stuff, come on over to Twitch. Otherwise, thank you for stopping by, whether you're on Twitch or YouTube.